I want to thank you all for joining us and let you know how excited we are to be with you today to talk about data observability and how it can help you improve your data quality. Just a bit of housekeeping before we get started. If you have any questions today, please put them in the Q&A box. The session is being recorded and you will receive an email following the webinar with a link to the recording and the slides. I'd like to introduce our speakers for today. First is myself, Julie Skeen. I'm the Senior Product Marketing Manager at Precisely, responsible for data quality and data observability. And with me, I have my colleague, Shalaish. Shalaish, can you introduce yourself?
Thank you, Julie. Hello, everybody. Thanks for being here today. I'm Shalaish Koul. I'm part of the sales engineering team here at Precisely. Been here almost 4 years and can be excited to bring to you what we have to show today as part of our data observability webinar.
Thank you, Shalaish. The plan for our session today is to share some introductory information about data observability. We will then discuss how data observability works and show you some use case examples in action. We will allow time at the end to answer some questions. Let's jump in. Here you see a few statistics from Forbes, the Harvard Business Review, and Precisely's own data trend survey. Looking at these, when 2/3 of organizations say siloed data negatively impacts their data initiatives, and almost half of newly created data records have at least one critical data error, it's no wonder that 84% of CEOs doubt the integrity of the data on which they make decisions. Let's learn how data observability can help. There are a number of business challenges that occur that can be improved by using data observability. See if any of these things sound familiar. Something goes wrong with the data pipeline that impacts downstream operations or analytics. You might experience this as an email from IT saying your BI tool is unavailable. Or do you ever experience a lack of confidence in decision-making based on the data in your BI tool or advanced analytics processes? Did your team find that writing scripts or other manual methods that were used in the past to look for operational data issues no longer scale as volumes increase? If any of these challenges resonate with you, then your organization can benefit from a data observability solution. So, what is data observability? Observability itself is not actually a new concept. It started over 100 years ago and is a key concept in many process methodologies and is used in industries such as manufacturing, as well as software development. What is newer is applying these concepts to data. Data observability ensures the reliability of your processes and analytics by alerting you to potential data integrity events. It answers the question, is my data ready to be used? And when we say used, we mean anywhere a business depends on the data being accurate. This obviously means a lot of things to a lot of different people. If you're dependent on a BI report, you may ask if the data that's feeding the reports is correct. If you're a data engineer moving data through pipelines, you want to know the data is being transferred correctly. And if you're a data scientist building advanced data science models, you want to know if the models are reflective of recent data changes or if they need to be retrained. Take, for example, a simple process where the finance department makes a business decision based on a daily report of online orders. If for some reason the data feeding the report from the source systems is incorrect, the insights and outcomes based on the report will be flawed with obvious negative downstream impacts. If this all sounds similar to data quality, that's because it is another way to ensure the quality of your data. We'll talk more about how data observability relates to traditional data quality in a few minutes. First, we want to talk about why data observability is more important now than ever. We all know businesses are using data for more purposes and ultimately becoming more dependent on it. Think about if you were driving a car while looking at your phone. Your primary goal is to get from point A to point B safely, but if you're constantly inundated with distractions, you're trying to look at your phone while you're driving, this can cause you to drive off the road or collide with another vehicle. The same applies to your business. Your objective is to run your business, but if you're constantly distracted worrying about data issues that might happen, then you're going to drive off the road. Similar to the gauges in your car, you want only relevant alerts, help you drive your business successfully. The data issues are more relevant today for a variety of reasons, but they can be grouped into two main categories: data proliferation and technology diversification. So what do we mean by that? Data proliferation, I mean, there's more data, a lot more data. A Forbes study estimates we're creating 2.5 quintillion exabytes of data every day. That's data that's spanning a variety of locations: cloud, on-prem, hybrid cloud, not to mention the data moving between those different locations. And by technology diversification, I mean there's pivotal business transformation initiatives occurring, empowered by amazing next generation tech that represents a rethinking of established legacy systems. These efforts almost always span a diversity of vendors, applications, and technologies, such as streaming, IoT, and AI and ML. Data consumers, users, and producers cannot take their hands off the wheel to validate that the data is ready for use, as they need to stay focused on steering the business. Data observability enables business value not only when fast insights allow for quick decisions, but also when the data being used for insights is trusted. So it's one thing to identify data issues, but more important, the data issues need to be corrected before the data is used for making decisions. Data issues will happen. No system or process is perfect. Proactively addressing issues prevents them from impacting the business. As you can see in this picture, data observability shines a light on your potential data issues with passive user interaction. This captures the essence of data observability and just how simple it is to shine a light on a potential problem and change course versus having to salvage the wreckage later. So there's one takeaway from this overview. Please remember, data observability is proactive and intended to improve data reliability and reduce data downtime. Using a variety of techniques, data observability surfaces issues in source systems before they become significant. We're going to show you a few examples of those techniques, such as those based on volume and data drift detection methods. And they answer questions such as, is my data ready to use? Do I have all my data? Do I have the right data? And with data proliferation and technology diversification at play, reactive methods simply do not scale. They're error-prone and resource-intensive. And as that old adage goes, an ounce of prevention is worth a pound of cure. The process of managing the data lifecycle and data journey and monitoring an enterprise has become incredibly sophisticated and complex. It's not out of the ordinary to see thousands of pipelines and transformations spanning hundreds of different data sources. Data quality is often validated at that final delivered stage. Comparing this to a traditional manufacturing process, it's the equivalent of ensuring the quality of the finished product with a post-manufacturing inspection. And as you can imagine, this process is incredibly costly from both a time and risk perspective. And the same concept applies to your typical data products, such as analytics, reports, applications, and any pipelines or processes that are driving an outcome. For a data pipeline, it means a stakeholder is finding the issue and reporting it to the creator of the analytics. Again, it means having to go back to an earlier stage after the production is thought to have been completed. Contrast that process with what it looks like when you add data observability. Data observability enables the user to visualize the data process and see deviations from the typical patterns. What that means in this example is you see a typical data process that spans multiple data sources and transformations. This is obviously a simple view, but in reality, there could be hundreds of different transformations spanning different data sources. And as it moves through the pipeline, it's observed at each stage, ensuring the entire process is stable. Data source number 3 here is applying enrichment as well as blending and merging of data. You can see there's some sort of anomaly that has the potential to jeopardize the final data product. Catching it early in this stage allows the appropriate resource to be notified. The issue can be assessed and resolved before the data is made available for consumption. Many studies, of course, have been published validating the cost savings of finding issues earlier in a life cycle, and this cost savings can be significant. The early resolution eliminates wasted time and resources in later stages of the pipeline, not to mention the risk of negative business outcomes. It's critical that data issues are discovered and remediated before business decisions are made based on inaccurate analytics. Okay, so how does data observability work? It's really broken down into these three main sets of capabilities. The first here, discovering the data that you want to observe and collecting information about those assets through a variety of techniques and tools. The second component performs the analysis to identify any adverse data integrity events. The analysis can get quite sophisticated. It often implements modern AI and ML methods to crunch massive amounts of metadata and related information. And finally is action. And that's bringing those alerts and insights to the forefront for both manual and automated resolution. And it's essentially the step to do something about the data issues that have been found. Let's look just a little bit deeper at the capability of data observability analysis, anomaly detection. It just might not be obvious when we talk about the analysis component of data observability that the underpinning of this capability set is extensive intelligence empowering those insights. Outlier detection for identifying anomalies has been proven to be an effective technique in many use cases, and it's an integral part of data observability. Here you can see a few typical patterns of anomaly detection used in data observability. This is just scratching the surface of AI and ML methods that are used to determine outliers. If you're familiar with these types of methods, you see it includes a variety of things such as random noise, step changes, trends, and others, many of which are very complex. If you aren't as familiar with those specifics, the main takeaway here is that there's an extensive artificial intelligence and machine learning that is supporting the anomaly detection, so that while you can build specific rules within data observability, you don't have to, because the system will learn what to expect from your data, and it'll alert you when anything appears outside the norm. When we look at data observability and traditional data quality, we consider them as complementary capabilities, and there is some overlap. Data observability may be sometimes under the same umbrella as data quality, or it can be owned in other places such as DataOps. But both focus on the use of metadata and the traditional data quality dimensions, those things that we're familiar with like accuracy, completeness, conformity. Both benefit from integrations with things like data catalogs and are critical for any data governance initiatives. The biggest difference really is how each capability set performs this evaluation. Data observability emphasizes the identification of anomalies and outliers in the data based on patterns over time. Think of this as similar to human inference, or like how you or I would take a data trend line and draw a conclusion, versus the static predefined rules you typically find part of data quality tools. While we at Precisely offer both data observability and data quality as distinct capability sets, we also make sure that both sets of functionality complement each other to ensure customers get the most possible value from the solution. The other capability that is critical to data observability is an integrated data catalog. There are a number of benefits we see from having a data catalog integrated with data observability. The catalog provides a single searchable inventory of data assets and allows technical users to easily search, explore, and understand their data. It allows users to visualize relationships, the lineage, and the business impact to data, and enables collaboration through a variety of different mechanisms. It also enables data stewards to monitor, audit, certify, and track data across its lifecycle. So with that, we now want to show you some examples of situations that happen when things don't go as planned with data pipelines, and give you a view into how data observability helps to address each of these scenarios. So I'm now going to turn it over to Shalaish.
Thank you, Julie. That was very insightful. And thank you, everybody, again for joining us today. So today, we're going to cover the following in the demonstration. Well, we're actually going to start with alerts, and I'll walk you through the entire life cycle of what an alert is. Then we're going to backtrack, and I'll show you the steps that I have actually performed to monitor my critical data assets so that I get an alert every time there's a data anomaly. Last but not the least, we'll take a look at some of the profiling capabilities that lend itself as a self-serve data discovery tool. All right, so when I log on to the alerts page on the data integrity suite, I get a summary of my environment at the top here. So I get I get different kind of alerts that have been generated, whether the alerts, all the details that are related to those alerts at the bottom here. So I can look at all the details that have been created as part of those alerts. Uh, Within the alerts, I have these details available as well. For example, where the alert is created, what kind of data asset it is, where does that data asset actually reside, what's the criticality, and we'll see how we configure that criticality later, but what type of alert it is, and then how many assets are actually impacted as part of that alert. And finally, when the alert was raised. Now, we can drill down into an individual alert and find out more details and start investigating. For example, the first alert I have here is about a schema drift. Now, it's quite common that new tables get added in your environment, the data structures change, data type changes, and so on and so forth. Observability enables us to stay on top of all these changes without relying on manual communication channels. As I can see here in these two assets, there was a column deleted and there was a column added. And I get all the other details that are associated with what table this is, what schema does it reside in. For example, in this other alert, I can actually see that there was a data type that changed. Now, it's important as a downstream user for everybody to find out that an asset that they've been leveraging has had a change. And whether it's a new table added, do they want to leverage that new table in their processing? Whether it's a data type that has changes that has a potential to break the downstream applications. So they need to make changes to accommodate that change. Another example we have here is for a data drift. Now, we capture all the changes that happen at the granular column level, the data that sits in those rows and columns in your tables. As Julie mentioned, we leverage a lot of artificial intelligence and machine learning models to capture trends and ranges of data, and then generate an alert if any new data that comes in falls outside of the range. I'm trying to simplify it, but that's essentially what it is doing. We're watching the data, we're capturing those trends, and then we look at what came in next. And if it falls within that range, it's good. If it falls outside of the range, we want to let everybody know and generate an alert on top of that. So let's take this example. I'm looking at this currency asset here, which belongs to this asset parent. It's a critical alert. And I have these charts here that help me investigate. I can see all the different statistics that are impacted as part of this. I can go through all of these charts, and let's take a look at this example. So we look at all things like the minimum values that came in, the maximum values, the mean of the data. We calculate that on a daily basis, the standard deviation, all of those things happen. But along with that, we're also capturing, for example, in this scenario, is the distribution of data. As you see in this example, this is the Great Britain pound, which had a historical percentage, a distribution of 20%. 20% of the records that came in had a currency of Great Britain pound. And that percentage suddenly dropped to 11. That's a big change in the distribution of how my data came in. And that's worth noting. That's worth notifying every user because that's a change in how I used to run my business. And that's beyond the typical data quality anomalies that used to happen with a bad value, a fat fingering going into the data, causing a data anomaly. But this is more around the overall structure of the data that I'm used to having. Another example is the volume change, which is quite simple, as you can easily follow the change in the actual rows of the data, for example. Now, historically, we maintain the trend of how many records do I expect on a run over run basis, a day over day basis. And if that trend changes, I need to be notified. For example, in this case, I had on March 2nd, there were 40,000 records that came in. And on March 3rd, that row count went upwards of 135,000. That's a huge change, and I want to know about it. Now, along with this, there are more details on the details tab here where you can find all the information about the asset and the alert. So you can see when the alert was created, what type of alert it is, the configuration details, all the asset information that is available, and the tables, the schemas, and the impact that it has. What we also capture is the popularity metric. Now, this tells us how widely the asset is being used within the organization so that we can take appropriate action. Now, that takes us to the overall life cycle of an alert. Now, what do we do once an alert gets generated? There are several actions that you might take. You might consider that alert as non-critical and see that this is okay. You have an option to close the alert. So let me just highlight this. You have an option to close the alert. So what that does is feeds back into the machine learning model so that the model keeps improving and you do not see that alert again because you've deemed it harmless. The other option, if you have a separate case management, which is the case with which is the scenario with a lot of our customers, you can actually link this with that case management system. And I have ServiceNow configured here in my tenant, so I can actually go ahead and start creating a ServiceNow incident and provide all the details that I need to provide and have someone start investigating on this incident, a data engineer or a data steward. Uh, Julie talked a little bit about the catalog and the interoperability that we had, which lends itself to the overall lifecycle management of an alert. We have options to actually start remediating an alert. So we have the data quality capabilities along with the data observability capabilities, and this is where they start complementing each other. So as I see an alert, I have an option to actually start remediating it right there and then. I can start creating a data quality pipeline and start fixing this issue before it becomes catastrophic. I can also go into the asset details and leverage our governance platform to actually take a look at the impact analysis diagram and the lineage diagram. We're not going to go there today because we're focused more on the observability side of things, but we have capabilities to actually track the data all the way where it originated from and where it's going to ultimately land to see that end-to-end picture of what impact can this asset have if it has bad data in it. So this was about the alerts overall. So now let's kind of roll back and see how did I get here? How did I actually start getting these alerts? So it started by creating observers. So I can actually go in here. It's a very intuitive interface. We leverage the common catalog. So everything, all the connections, all my data sources, they have been cataloged and they are available across all the different modules, whether it be data quality pipelines, whether it will be data replication pipelines, observability, governance. I have all of this data cataloged so everyone has access to everything. So I can go in here and start actually looking at the data that is critical to me that I want to leverage, and I can start looking at the tables and start creating observers. So I can go in here, select the columns that matter to me that I'm going to use, and I want to make sure that the data quality and the data in those columns stays good and of high quality, and I can start creating some of the observer rules. Now here's a list of some observer rules that we have here. So let's take a look at the volume, which is the easiest. So how do we go about looking at data in terms of the volume? So I have a table. I want to make sure that the data that comes into that table from an external source or from an upstream system always stays within an expected range. So I can configure those rules here. I can let the AI and the ML driven model govern that altogether. Or if I know my data, if I know my business and environment, I can actually set up my own rules. I can leverage moving average. I can leverage some data points from the past, as many as runs. I can look at the last run and kind of create those thresholds myself because I know that I do not expect a deviation of more than, for example, 8% in the volume of data that comes in. And if on any given day I get a volume which is 8% more than a mean which has been historically created, I need to be notified because that might be because of a problem that might happen in the upstream environment. We have data drift. We look at a lot of things in the data drift, the completeness of the data, uniqueness for the numeric data, the mins, the max, standard deviations. We also look at the textual data to look at the lengths. We also look at the distribution, the example I talked to you about. And this is again where I am allowed to set up the thresholds that I want to categorize those alerts as critical or warnings. We have the schema drift, which we looked at a couple examples in the alert. I want to know about anytime a table is deleted, a column is deleted, a new column is added, any data type changes. I want to know about it because I want to make changes in my downstream applications, or I want to leverage that new data that has been added in my processes. Last but not the least, the freshness of the data. I'm leveraging my data. I want to know whether it's fit for use. So I want to make sure it's not stale, it's getting updated at the frequency it should get updated at, and only then I can be confident in starting to actually use that data for my processes. Last thing we want to talk about is once the observers are created, we did want to talk about the profiling capabilities. So profiling allows us to sort of perform a self-serve data exploration. So it automatically creates a profile for everything that has been cataloged. So all of my data is not just cataloged, but it's also presented to me in this view where I can now start drilling into my tables and look at the KPIs that are important. For example, completeness, popularity, how many tables are used, which tables are most used across my organization, what are the different metrics on each of those tables in terms of their uniqueness, in terms of their popularity, what are the different statistics around those, and I can start drilling down into individual columns as well to find out details about a specific data asset. And it'll give me all of those details about that asset as well, the different frequency analysis, the string length analysis, and these details are captured for each and every run. So this is already scheduled, so I can go to the previous run and actually find out details about what happened yesterday. So this becomes a very useful tool for someone who wants to actually go into the data and perform a comprehensive data quality assessment without having to fire SQL queries on the data, without having to be technically astute to get the data out of those sources. It's all presented in at one place with all the access where everything is running in an automated fashion. Okay, so that's all I had from a demonstration perspective. So let's go and take a look back at what all did we cover today. So we looked at how the alerts are created and how do we actually manage those alerts, whether those alerts are created for volume changes, the data drifts, schema drifts, freshness. We looked at multiple scenarios and how do you manage the entire life cycle of the alert. You have abilities to close an alert, you have abilities to take action, and you also have ability to actually get notified through emails about an alert that is happening, or you can create a ServiceNow ticket or send it to a case management system that you've been using. We saw how we leverage the integrated data catalog, which allows us to, again, contribute to that life cycle. For example, creating a data quality pipeline right off an alert, looking at the asset details to find out where the data has originated from and where it will eventually go. For all of these things to happen, an integrated data catalog becomes a foundational capability. We saw how we created and configured different observer rules, and then we saw how we can leverage the profiling capabilities, the automated profiling within observability as a self-serve data discovery tool. I hope this was helpful, and please feel free to post any questions, and I'll hand it over back to Julie.
Thank you, Shalaish. Now that you've heard about what data observability is and seen how it can apply to specific use cases, I just want to review the benefits of data observability. Many of these may be apparent to you from what you've seen. First is understanding the data health. As a system continuously measures and monitors what's happening, you can utilize dashboards to understand the health across your data landscape. Data observability can reduce the risks associated with erroneous business intelligence and advanced analytics that have the potential to impact a variety of business decisions. Proactive alerts are provided when the intelligence determines there's an anomaly or outlier, and that notification is shown both visually and pushed out to the appropriate users. Data observability also enables you to reduce the time to solve operational issues and reduce the cost of potentially adverse events. And finally, it allows you to quickly remediate the issues, and the integrated data quality capabilities further expedite this process. Before I close out, I want to mention that the product you saw today is Precisely's Data Observability Solution, which is part of Precisely's Data Integrity Suite. The Precisely Data Integrity Suite is modular, interoperable, and contains everything you need to deliver accurate, consistent, contextual data to your business. The Precisely Data Integrity Suite is a set of 7 interoperable modules that enable your business to build trust in your data. The suite has been built so you can start wherever you are in your data integrity journey. This means that the modules are designed to be implemented either together or standalone with best-in-class capabilities. For example, you can start with data observability, as we discussed today, and layer in other modules over time. Here you can see the brief view of the modules of the suite. Now it's time for questions. So before we finish up, Shalaish, taking a look at the questions we have here, the first one I wanted to tackle was, how does data observability work with other applications?
I think we covered a little bit of that, Julie, as I think you mentioned, and I kind of showed a little bit in the demonstration as well. Data observability is a complementary capability when it comes to a lot of things, because ultimately what we want to do is deliver accurate, consistent data. And while you look at the alerts, it's important to manage that life cycle of the alert. You want to be able to remediate that alert, because it's good finding out that there's a problem, but it's even better when you know that you can solve that problem without having a downstream impact. And then to assess that impact, I think that kind of dovetails into how it works in terms of your metadata management with your governance capabilities of how you can track that where does this data move within the organization and where does this end up? So how many reports, how many analytical engines are actually impacted? And I think that's where data observability kind of works complementary to all the other data management capabilities.
Great, thank you. So just, I think we have time for maybe one more question. What type of user would use data observability?
So there's historically, it's been data engineers who have kind of worked in that space, but I would say the ease of the technology which works behind the scenes has kind of made it easier for even the non-technical personas like data stewards or data quality stewards to kind of leverage this tool to make their job easier. So I would say the data engineers, data stewards, data quality stewards, I think they will all find it very valuable to leverage the technology to make their job easier.
All right. Well, thanks, Shalaish. Those are all the questions we have time for today. If we did not get to your question, we will follow up with you via email. Thank you for joining us today. If you would like to learn more about data observability, we have provided a resource for you here. Thank you for your time and attention.